Hey guys, welcome to my channel, and in today's video we are going to solve one more LeetCode question. So that is question number 979. Distribute coins in binary tree. So this is a medium level question, and in this question we are given a root of a binary tree with n nodes, and each node is having a value which is termed as coin. So there are n nodes, and if we are going to sum up the value of these nodes, the value is also going to be equivalent to n. That is, there are n nodes and n coins available in this tree. And what we have to do is we have to distribute these n coins in this whole binary tree in such a way that every node is having exactly one coin, or the value of every node is equivalent to 1. And we have to do this thing in minimum number of moves, where move is simply a movement where we are moving one coin from one node to another, and we can only move one coin from one node at a time. We can see in this example as well, the root node is having value as 3, and the total number of nodes in this tree is also equivalent to 3. So in this way we know that we have to distribute this 3 into these 3 nodes. So let's understand this question even better with this example. These 3 diagrams are not different, they are same. I had just made it to make it easier for me, else explaining in one diagram becomes a bit messy. So that's why I drew. We can see that in this diagram we have a node as value 2. So now if we have to distribute these 2 coins, what are the choices? So I can either give this 1 coin to its parent node, or I can give this to this leaf node or child node, right? I have 2 choices. Suppose I gave this to the parent node. So this node will become 1, right? But is this the correct way of distributing the coins? Because if we see, this node will become 1, right? After giving that 1 coin to its parent, this node will also become 1. But now how I am going to make this node value equal to 1? I have to then start distributing the coins from this node, and they will traverse this whole tree and come up to this place. Correct? Then only it is going to get this 1 coin. But if I would have shared this 1 coin with the leaf node rather than the parent node, then I wouldn't have traversed this long and made these many moves in order to make this distribution even. So what I realized is that I should not start distributing from the parent node or the root node. I should always firstly look after the leaf node, because that will make sure that the leaf nodes are satisfied or the distribution is optimal. Else I have to make multiple moves, and in a way these moves are unnecessary, right? Because we have to go for the minimum number of moves. So if you want minimum number of moves, we should firstly satisfy the leaf nodes, because at the end they are only connected to the parent node and they can only take nodes from their coins from their parents. So firstly we need to satisfy the distribution among leaf nodes, then only we will go to their parent, and in this way we will go to root node. So let's understand that with this tree. That's why I made these many trees, because see, I just explained one point and that whole diagram is messy. So what we realize that we have to start the distribution from leaf node. So let's start distribution from this leaf node, correct? So what will happen now is, we know that our distribution is going to take place in such a manner that all the nodes are going to have value 1, or every node is going to have exactly 1 coin. So for that, what I see is there are 4 coins in this node. So for satisfying the distribution condition, what I need to do, I need to remove 3. So what will happen is this node will give 3 nodes to its parent, correct? Then I'm saying, as I have to check leaf nodes first, so I will check this one as well. So I see that its value is 0, correct? So it need 1 node from its parent. So this node will take 1 node from its parents. I am writing it as -1. Fine. So this is what I observed in this small tree. And in this manner, what will be the value of root node after all these distribution? After all these distribution, the value of this root node or the parent node, a root node I am saying just because I am considering this as one small tree. So root of this subtree or the parent of these 2 child nodes, value is going to be 2. Let me just change the color. So this node's value becomes 2, correct, after all these distributions. Now what will happen is this node also needs to have that even distribution condition, right? So this node also needs only 1 coin. Rest of the coins will be returned to its or will be given to its parent node. So it will give 1 coin to its parent. Now what we need to do is, we need to again do the same thing with this side. We are saying check the leaf node first. So I check the leaf node. The value is 1. So there is no need of making any change. This distribution, this node is already having the required number of coins. So what I can do is, I can check the another leaf node. So this node is having 0. So what will happen? This will demand the parent node that I need 1 coin. So this will be -1. And this will return 0 because this doesn't need anything. So what will be the value of this node? The parent node. The parent node will give 1 node to this leaf node and will become 1. Right? And so as this node is also having 1, so it is having the adequate amount of coins. So this will also tell the parent that I don't need any coin because I already have 1 coin. So now what will be the value of this node? This node will have 1 because it is coming from this place. So now what I observed is, when we are checking the leaf nodes and we are returning the requirement, that is whether a node is returning the extra coins to its parent or whether the node is asking for a coin from its parent, we are getting the value by adding it up. So what we can see is, let's see this tree, this much subtree. So the root node, this root node value which we saw in this diagram is equivalent to what? Is equivalent to 3 plus -1 plus 0, correct? And this will become 2. So how we got this 2 is, we got the value from the left node, then we got the value from the right node, and we added up the current value. What is the left node value? Left node value is the value that the node returned, or the extra number of coins that the node gave back to its parent, and this -1 is the number of coins that the node is demanding from its parent. And after summing up with the existing value, we got the current value of the parent. So in this manner, we are going to calculate every node's value, whether it's a leaf node or a parent node, we are going to get the value by performing this calculation, where we are going to check firstly the child nodes, then we are going to get the left and the right node demands, whether they are giving the extra coins or asking for the coins, and then we are going to sum it up with the existing value, so we will get the exact value of that node. But we are not going to update any node in place. We are not going to make any change in the tree. We are simply going to keep on updating these values, the left coins and we are simply going to keep track of all these coins and their transaction. But the main thing that we need to check while we are performing all these operations is the number of moves. So what are the number of moves that we made? So number of moves are nothing, just the sum of these coins or these demands or these left and right node coin values. So if I'm going to sum up these values, absolute values, not the -1 will be kept as -1, no, it is going to be kept as 1. Why? Because if we see this tree, so this node is going to return 3 coins to its parent. Return or give, I'm messing with the words, but you get it what I'm trying to say. So I'm saying that this node is giving 3 coins to its parent. So I know, as per the condition that is being stated in the question, I am able to move 1 coin at a time, and that will be counted as 1 move. So if I am moving 3 coins from this node, so I am making 3 moves, correct? In the same manner, this node is asking for 1 node from its parent. So that means this node needs 1 coin, and 1 coin will be distributed to this node by making 1 move. So in this manner, this node is going to have 1 move, correct? And similarly, the whole tree is having the same calculation. So I am going to simply add the number of coins, whether they are given to a parent or been asked to parent, and the absolute sum of all these values are equivalent to the number of moves that we are going to make in order to distribute these coins evenly in this binary tree. So this is the whole solution. I know that you all will be having so many doubts. So just to make it clear to you all, let's do a quick try run of this whole approach that we discussed, so that it will be more clear to you all. Now we have discussed some points, and on the basis of those points we decided that we are going to start our traversal from leaf nodes, right? Because we want optimal distribution and optimal number of moves, and to get the optimal number of moves, we are going to start a traversal from leaf nodes. But if we see the pattern that we followed, what kind of traversal we are going to use? Now this is pretty clear that this question is about tree, and tree questions are solved using either DFS or BFS. But in DFS as well, there are 3 types of traversals, that is in order, pre-order or post-order. And as per our condition and as per the solution that we just saw, the approach that we just discussed, we will proceed with the post-order traversal, where we are going to firstly check all the leaf nodes and then we are going to go to the root, so that we are not going to make any unnecessary move. We are always making optimal moves, because children are only connected to their parents, or the leaf nodes are only connected to their parents, so they won't be able to get nodes easily if they are not served first. So that's why we are going to solve this question using DFS, post order traversal. So now let's see the dry run. So as we are going to start As we are going to solve this question using post order traversal, so firstly we will go to this root, but then we say we will, as we are doing post traversal, so we will go to the leftmost node. So we will come to this place. So here we saw that the value is 4, so we are going to keep 1 and going to return rest of the coins. So this will give 3 back. So this will give plus 3. Then I am saying check the next leaf node. So this is saying I am having value 0, that is there is no coin, so I need 1 coin. So this is going to return -1 to its parent. So now what is the parent's value? Parent's value will be, we are not going to update the value, but what we are going to return to the further recursion is that +3 -1 plus 0, so it is going to give 2. So we are going to return 2, so this value will become 2. So again what we have to do is, from this 2 we are going to keep 1, right? From this 2 we are going to keep 1 and then we are going to return the rest to its parent. So this will become 1 and this will return 1. But when we calculated this 2 at the same time, what we are saying, update the moves as well. So what will be the moves? Moves will be 3 plus 1 plus 1, right? So it is equivalent to 5 till now. Now when we come back to this root, we are saying we are doing post traversal. So now let's traverse the right subtree first. So again we will go to this node, then we will come to this node. We will see its value is 0, so it is going to return 0 to its parent, and this is going to return -1 because this needs 1 node. So once again we are going to do the same thing, 2 plus 0 minus 1, this will give 1. So now as this node's value is already 1, so this will return 0. And till now what are the moves? Moves is 0 plus 1 plus 0, that is plus 1, so this is 6. So now at this point this root's value will be 0 plus 1 plus 0. Current value plus the left coin plus the right coin. And this gave us what? This gave us 1 for this node. So in this manner, how many moves we made? We made 6 moves. So 6 is the answer. And this is how we achieve the answer. When we are calculating the root, at the same time we are updating the number of moves for that subtree that in which we just distributed the coins. And in this manner, we will solve this whole distribution using post order traversal and recursive DFS. Now let's discuss the time complexity of this approach. So as we are going to traverse every node or each node exactly once, so the time complexity is going to be big O of n, and we are not doing anything else rather than this. The calculation that we are doing will take big O of 1 time, constant time, so it is not going to affect the complexity. So this is the time complexity. And space complexity is going to be big O of n. Why? Because we are going to call DFS recursively, right? We are doing post order traversal but using DFS. So because we are doing this recursively, so there will be a call stack, and in worst case scenario, if the tree is completely unbalanced or is a left or right skewed tree, in that scenario the recursive call stack can goes up to the size of number of nodes, and in that case the space complexity can be big O of n. So considering the worst case scenario, space complexity is going to be big O of n, or else it is going to be equivalent to the height of our tree. So this was the space and time complexity. Now let's quickly code this whole approach. So in this question we have to return moves So firstly, let's define that. Now moves is something you can either create a variable and pass it on in your DFS function, or else rather than doing this you can simply do self.moves. So it is going to be accessible from that DFS function that we are going to create. So we are going to return self.moves at the end, right? Now we are saying we are going to call DFS recursively on our tree, and we are going to perform post order traversal. So let's define our DFS function then. DFS, and in this there will be a node, and as we are doing recursion, so there will be a breakpoint. So it will be if node is none, in that case return 0. But if it is not none, in that case, as we are doing post order traversal, we are firstly going to traverse the left subtree, then right subtree, and then we are going to work with the root node or the parent node. So we are saying now call DFS on node.left and also on node.right. After this, I am going to firstly update the moves, that is self.moves plus equivalent to absolute value of left coin plus absolute value of right coins. And after this, just return what? Return the node.value -1, because we are going to keep 1 now. We only have to keep 1 and we are going to return rest of the coins. That's why we are doing node.val -1, and we are adding the left coin as it is plus the right coin. So this will balance out the distribution that is needed to be done. So I think that's it for the code. Now let's quickly run this and check. So we can see that this is accepted, and yeah, this was the whole explanation and solution, and I hope this explanation was helpful for you all, and if it was, then don't forget to like, share and subscribe my channel. I will soon come up with more such questions, and thank you so much for subscribing, because we have already crossed 500 plus subscribers, and that is really awesome. That motivates me a lot to create more such videos. So thank you so much, and I will see you soon with more such questions. Till then, keep messing with algorithms, and thanks for watching.